like?
Well, because I finished it.
Thank you, Roger. That helped. That helped a little bit. That was for effect. All right. Anyway, now that we're at this stage, all we need to do is simplify the right-hand side wherever possible. It's not possible. And we will simply multiply both sides by y, which really just means multiply it over here, right? Take it and multiply it over here, and rewrite it as what it is x cos x. So y prime now, the thing we were trying to find all along, is x to the cos x, y, multiplied over here, times the expression we have. Cos x on x minus sine x ln x. Lx, yeah. Sine x ln x, that's the product. There. There's our answer. Okay?
Did you do the product rule on that?
I did a product rule, yeah. I did a product
The
rule.
back of sine x times.
Wait, what? I don't know.
What's that?
Did you do the back of sine x times ln x? Oh, that's what you're getting.
I just rearranged, that's all I did. I don't even know why. Okay. You want to do another one? Or you guys feel comfortable with it?
Not comfortable.
Okay, let's do one more. Do one that's not as obvious. I'm not saying they're obvious, I'm saying it's less obvious, even. '71. Just want to get through this so we get to the next section. That's why I was probably a little bit quick there. Corning, I'm sorry. X. You need to find this derivative. Again, start out with just writing this as the function 1 plus 1 on x to the x, meaning 1 on 8 to the x. Apply your natural log. Simply for the sake of removing the exponential portion and bringing it down to the front as a coefficient. So ln 1 plus 1 x to the x. So ln y is x ln 1 plus 1 x. All right. So again, it's a product rule on the right-hand side, so we should expect almost every time. So the left-hand side, we take the derivative, and d dx both sides now. Gives us y prime on y. Does everyone understand why it's y prime on y? You understand why, according to the implicit differentiation, chain rule should be that way? If you don't, it's okay. I mean, just write y prime on y, but we better understand it if possible. I'm taking the derivative of ln y with respect to x. So what's the derivative of ln y? It's 1 over y, right? But you got to keep the inner function inside, so 1 over y stays there. Then to finish on the chain rule, I've got to take the derivative of the inside and multiply it onto it. So I did. Right? I think that is a complete understanding. So now, the right-hand side is first times the derivative of the second. We need the derivative of ln 1 plus 1 on x. So the derivative of ln 1 plus 1 on x is going to be, what's that? Is it? So you could do one of two things here. You could make this into a single fraction first, or you can work with it as not making a single fraction. It's whatever you want to do. But in a second, you're going to have 1 over this expression. So you're going to need to simplify it anyway. So you might as well write it as a single fraction now and work with it the whole way.
Try to make it a single fraction.
Okay, it's x plus 1 over x. That's pretty straightforward. So, if we take the derivative now of natural log, right? First times the derivative of the second. The derivative of natural log is going to be the reciprocal of the inside. So x over x plus 1 times the derivative of x plus 1 over x to complete the chain rule. Right?
Wait, why is it at the bottom? Why did you flip it now?
The derivative of natural log is 1 over whatever's inside. That is the reciprocal of what's inside. So the reciprocal of what's inside is x over x plus 1.
That's not. So x plus 1 over x that's a function. That's a function.
That's a function put inside the natural log. Exactly right.
Natural log is a function itself. Right?
Correct. So this is a composition. I've got x plus 1 over x, that rational function, put inside the ln.
Why don't you do chain rule first before you went into?
That is chain. This is chain rule. This is the chain rule for this. You're saying back here?
Yeah, just that.
No, because I got this guy.
But you would pull that on the front.
That's what we just did.
Yeah, but I mean, like you still still have that function still inside ln. So you have to find the derivative of ln and then find the derivative of x plus 1 over x.
Correct.
Yeah, that's the derivative of ln.
No, that's the derivative of ln.
Yeah, that's what I mean.
Times the derivative of the inside. That's what you said. I have in symbols what you said in words. Right? Crawling on me? Alright. Plus second ln x plus 1 over x times the derivative of the first. Derivative of x is 1, so I'm not going to write it. Okay? It's not going to affect anything. It's okay now? It's a bit messy, but we just need to take this quotient rule, right? Right. We'll take this quotient rule off to the side. Derivative of x plus 1 over x. So bottom times derivative of the top. That's too easy. Bottom times derivative of the top minus top times derivative of the bottom over bottom squared. Okay? X minus x goes away. I have a negative 1 here. So this is negative 1 on x squared. Which makes sense if you think about it back here, right? 1 plus 1 over x, the same as 1 plus x to the negative first. You take this derivative, this will go to 0, you're gone, and then you're going to bring the power down, you get a negative x to the negative 2, but that's negative 1 over x squared, right? So either way you would have done it, you should get the same thing. So the reason we changed it was not because it made it easier for this part, it made it easier to think about this part, right? So it was a little more cumbersome over here with the quotient rule, but I think it was better to, when we're taking that reciprocal, it was easier to see what's given. Plug it in for this expression here, negative 1 over x squared. This is negative 1 over x squared. Y prime. I need to multiply by y over here. I'm going to multiply by y over here and put in the negative 1 over x squared, and then we'll simplify the whole thing. So y is back to the original 1 plus 1 over x to the x. There's y multiplied over here, times this x over x plus 1, the derivative, negative 1 over x squared. That quotient rule will turn out like that, plus the ln of x plus 1 over x. And now my, we'll put a bracket over here, right? The y is multiplied onto the entirety of the thing, right? Right, so does anything cancel? Yeah. You've got an x and an x here, and you've got an x squared down there. So those are all gone. So this expression here is really negative 1 over x plus 1. This one stays the same. And this one stays the same. Boom, messed him up. Just some Brazilian jiu-jitsu on him. Right, Raja? Yeah.
Got it.
Okay. It's pretty. I mean, once you do a few of these, that's pretty standard. So try to get used to these. I know they're getting more complicated fast. Right, the rate of change of the difficulty of the class is
What do you say?
nearly exponential.